Hey guys, so if you can turn to page 7 of your packet, we're going to take a look at solving basic logic equations. Now, I know last night for homework you had to watch a video that went over numbers 20, 22, and 24 on this page, and then it went over, I guess, 26 on the next page. So we're going to take a look at, the examples that weren't covered on the video last night. All right, so let me just kind of zoom in. We're going to start with number 21. Now, you may actually want to hit pause and try the three odd examples, 21, 23, and 25 on your own, and see how you do. Okay, then you could hit play and check the solutions. Okay, so if you remember, the first thing you want to do when solving a log equation is you want to get it out of logarithmic form. You want to get it into exponential form. So we do that by circling the base and running the race. Now, if you remember, what happens is when we take this base and move it to the other side of the equation, right, it finishes the race. This becomes the base on the 2/3, okay? So on the right-hand side of the equation, the base is going to be x, and 2/3 becomes an exponent. Now, when we do that, when we drop this base out of here, the word log drops off, right? It no longer holds the word log up, so we could just take the 64 and just bring it right down. Okay, and then all you have to do is just solve this equation. So if you look to the left, this is kind of similar to number 20. If you want to get rid of an exponent on a base that's a variable, all you do is you raise both sides of the equation to the reciprocal power. Okay, so the reciprocal of 2/3 is 3/2. Okay, so the reason we do that is because 2/3 times 3/2 is just one whole. The 2 on top cancels with the 2 on bottom, the 3 on top cancels with the 3 on bottom, and we can bring down the x. Now, if you raise the right-hand side of the equation to the 3/2 power, you have to do the same thing to the left. And if you remember from last night's video, even though it fits better over here on the left of the parentheses, make sure you put it on the right of the parentheses, okay? So on the left-hand side of the equation, we're raising the 64 to the 3/2 power. Okay, and whether you want to, plug that in your calculator or figure that out by hand, either way, you get 512. Okay, number 23, so same thing. We're going to first get it out of log form by doing circle the base, run the race. So when we do that, the 81 now becomes the base over here. So it's base 81, and that 1/2 becomes our exponent. Okay, and when we move the base out of the way, the word log drops off, and we just take this x and bring it straight down. Now this, we really have nothing to solve for. I mean, really, x is by itself, so we just have to figure out what's 81 to the 1/2 power. Okay, so whether you plug this in your calculator or do it by hand, either way, 81 to the 1/2 power is equal to 9. Okay, if you do it by hand, right, just think about power over root. This is the square root of 81, which is 9. And then 9 to the first power is 9. So we get x equals 9. Okay, and then number 25. So same thing. Let's circle the base and run the race. So that's going to leave us with x as the base to the -3rd power on the right side, and we're going to bring down the 8. Okay, now here we're trying to solve for x, and since there's an exponent on it, remember to get rid of that exponent, we're going to raise both sides of the equation to the reciprocal power. Now, technically, this is -3/1, right? So the reciprocal of that, if you flip that upside down, would be -1/3. So let's do that to both sides. So we know that a number times its reciprocal always equals 1. And by the way, if this is negative, you have to keep the negative with the reciprocal because a negative times a negative is positive. So these cancel off because it becomes 1. So we have x to the first power. And then if you figure out what 8 to the -1/3 power is, you could either do it by hand using your exponent rules, or you can use your calculator. Either way, you end up getting 1/2. Just to remind you, if you wanted to do this by hand, I'll do it off to the side. So if we had 8 to the -1/3 power. Okay, so since we have a negative exponent, right, what we do is, to make an exponent positive, we move this term to the other side of the fraction bar. So I'm going to take this 8 to the -1/3, and when I move it down here, it becomes 8 to the +1/3. And then we put a 1 on top as our placeholder. Okay, so we have 1 over. Now, if we do power over root. This would be the cube root of 8 to the first power. So the cube root of 8 to the first power. Okay, so basically this 1 is where we got this from. And then the cube root of 8, right? What times itself gives you 8? Well, 2 does, right? So the cube root of 8, and 8 to the first power is just 8, is 2. And that's where that 2 comes from. Okay, if you turn to the next page, 26 you should have done from the Ed puzzle. So I'm going to just kind of get that out of here. We're going to write to 27. All right, so if you want to try any of the examples on this page on your own, you can hit pause, and then you can hit play and see how you did. 27 is a long one, I'm going to tell you. So I'm going to kind of start to go over it. But again, if you want to hit pause, try it out on your own. That's definitely a good idea. All right, so same thing. We're going to circle the base and run the race. So when we do that, this x plus 3 becomes the base on this 2 right here. So we're going to have x plus 3. I'm going to put that in parentheses because I have to put a square on the whole thing. And then what I'm going to do is this word log drops off, and I just bring down the left-hand side of the equation. So I have x cubed plus x minus 2 over x. All right, so we know that when something's squared, right, it means there's 2 of them. So we're going to write it out twice and double distribute. I'm going to actually do that off to the side. So if I had x plus 3 times x plus 3, right, this means there's 2 of them. I'm going to double distribute. So I wind up getting x times x is x squared. X times 3 is 3x. 3 times x is 3x. And 3 times 3 is 9. And then when I combine my like terms, 3x plus 3x is 6x. So I get x squared plus 6x plus 9. Okay, so I'm going to rewrite the right-hand side of the equation as x squared plus 6x plus 9. And I'm going to put that over 1. And the reason I'm putting that over 1 is because this side of the equation is a fraction. So let me just bring down this side of the equation. All right, so you could do one of 2 things here. You'll get the same answer either way. You could either cross multiply, or I know what a lot of you guys seem to like to do is you like to say, all right, look, since they're both fractions, let me find a common denominator because then I can cross the common denominator out. So if you want to do it that way, since we have an x here, you can multiply top and bottom of this fraction by x. And then now that you see the denominators are the same, we can just cross those denominators right off. So I'm really left with the same thing I would have been left with if I cross multiplied. Because think about it, if you cross multiply, you would have had the top left times 1, which is just this, and you would have had the top right times x, which is what this says. Okay, so let me bring down the left-hand side of the equation. And then on this side, I have to distribute an x to all 3 terms. So that'll become x cubed plus 6x squared plus 9x. Okay, well, some of you may notice if you have an x cubed on the left and an x cubed on the right, they're just going to cancel off. I mean, and let me show you why. The reason they cancel off, if I subtract this, I have to do the same thing on the other side, which leaves me with no x cubed terms. And we really want to get, whenever you have exponents within your equation, you want to get everything to one side of the equation. I'm going to actually move everything to the right because this is my term with the biggest exponent, and it has a positive leading coefficient. And I don't want a negative leading coefficient. I don't want to move these 2 terms to the left and make my life harder, right? Instead, I'm going to move these 2 terms to the right. So in order to do that, I'm going to subtract the x, and I'm going to add the 2. So over here, I have to also subtract the x and add the 2. Okay, so on the left-hand side, everything cancels. On the right-hand side, well, I'm left with 6x squared. These combine to give me positive 8x, and then I have a plus 2. So 6x squared plus 8x minus 2. Okay, and then you could factor, make a t-chart, and solve, or you can use a quadratic formula. What I notice here, though, is everything is even. So if I take both sides of the equation and divide by 2, it's going to make my life a little easier. Okay, so we're going to factor. And since there's a number other than 1 in front of the x squared, let me just move this up. You guys are probably running out of room here, huh? Since there's a number other than 1 in front of the x squared, we're going to have to do the rainbow. So we know when we do the rainbow, we bring down the first term, we bring down the last term. Sorry, that's supposed to say, I don't even know what, it's supposed to say -3. I don't know what that said, though, but since 3 times -1 is -3, I have to come up with two numbers that multiply to -3 and that add to +4. Okay, that doesn't work. So what I'm realizing now is that I made a mistake up here. See that? +2. This should have been a plus, and that should have been a plus, which makes it +3. Now that works. Okay, so I'm going to make that a +1. So now we're on the right track. Two numbers that multiply to 3 and add to 4 would be 3 and 1. So I'm going to put plus 3x and plus 1x. Okay, and then we could just group. And don't forget to bring down the 0 equals. You always have to keep it in equation, right? So out of the first two terms, I'm going to factor out a 3x, which leaves me with x plus 1. And actually, the only thing I could factor out of these two terms is a 1. So I'm going to factor out a +1. Don't forget to put that plus sign in front of it, which also leaves me with x plus 1. All right, so I have 0 equals. Now we're going to group together the 3x and the plus 1. This is a really long problem. This problem is taking longer than all the other problems put together, huh? And then I'm going to bring down that common binomial factor of x plus 1. Okay, then we just make a t-chart and solve. So this side we get x equals -1. And on the other side we get, well, we have to take this and set it equal to 0. So if you subtract 1, it leaves you with 3x equals -1. And when you divide by 3, you get x equals -1/3. Now, technically, I shouldn't jump right into circling these because remember, we started off with, let me just slide back up here, if I can. There we go. With a fractional equation. See how this was a fraction here? And in the denominator, there's an x. So if we wind up with any x values that when you plug it into the denominator, create a 0, we have to cross them off. But luckily, both of these two values, right? If you plug this in, that's not 0. And if you plug in this in, that's not 0. So we can keep both values there. All right, so we have two examples down here. So we're going to do the same thing to start these off. We're going to circle the base and run the race. So when we do, this x plus 1 becomes the base on the 3. Put that in parentheses because we have to cube the whole thing. And then the log drops off and the 64 comes right down. Now, I just want to point something out. I want to go back to the last example for a minute. I'm going to come back up here to this one. Okay, see how here in this example we had a square and we knew we had to write it out twice and double distribute? Okay, now to get rid of a square, we could have taken the square root, but think about it. If we took the square root of this side, that would have been a mess, okay? And we could have actually raised it to the reciprocal power, which would have been to the 1/2 power. But to raise this to the 1/2 power would be a mess. Now, let's look at the one we have down here. Here, we have a cube. So we could take this and write this out 3 times and double distribute again, and we'll have a whole big mess over here. But since this side of the equation is just a number, wouldn't it be easier to either take the cube root to get rid of a cube, or let's just do what we did on the other examples. Let's raise both sides of the equation to the reciprocal power. The reciprocal of 3 is 1/3. Okay, so let's raise both sides of the equation to the reciprocal power. And this is going to make our life so much easier. Okay, so what happens is the 3/1 and the 1/3 cancel, leaving us with x plus 1. And 64 to the 1/3 power, you can either figure it out by hand or in the calculator, but either way you wind up getting 4. Okay, we're almost done. We want to get this x by itself. So let's get rid of that 1. And it leaves us with x equals 3. Okay, and then finally number 29. So we're going to circle the base and run the race. So this base goes to the right-hand side of the equation, and then the 1/3 becomes its exponent. Okay, and when we do that, what does that say under there? 4. The 4 drops right down. The word log comes right off. All right, so what we need to do is we need to get rid of this exponent because it's on the parentheses that contains the x. So to get rid of this exponent, we can raise both sides of the equation to the reciprocal power. So the reciprocal of 1 over 3 would be 3 over 1, which I'm just going to write as 3. So we know these cancel. So I can bring down the 5x minus 1. And then 4 to the third, right? 4 times 4 times 4. 4 times 4 is 16, times another 4 is 64. And then let's just solve for this x. So we have to get rid of this 1 by adding it to both sides of the equation. So we have 65 equals 5x, and then divide by the 5 in front of the x. So 65 divided by 5 is 13, so we get x equals 13. Okay, so if you can turn to the next page in your packet, this is going to be kind of the opposite of what we were just doing. In the last questions, when there was log on one side of the equation, you want to get that word log out of the equation. You're going to see here, we're going to actually do the opposite. We're going to put the word log into the equation to help us solve. Okay, so the difference here is that what we're doing in these questions is we're solving for an exponent. Okay, if you go back and look at the examples on the other pages, we were never solving for an exponent. But when you're solving for an exponent, actually logs help you. All right, let me show you how. So basically this is how it works. All right, the directions say to solve for x to the nearest tenth. Now, when you're solving for an exponent, what you're going to do, let me just give myself some more room here. What you're going to do is you're going to actually put the word log in front of both sides of the equation. And you're allowed to do that, right? You could put the word log in there as long as you do it to both sides of the equation. So we're going to rewrite this as log of 900 to the x power equals log of 1400. Okay, now the reason we do this is because there's something called the power rule. If you have a term with a log in it, you're allowed to take your power and move it to the front of the word log. So basically what happens is, see this x, it's going to come down in front of the word log. So it becomes x log of 900. And now this x is no longer an exponent. So it's going to make it so much easier for us to solve for. Okay, and let me just bring this log of 1400 down. Before I continue, I just want to show you in your calculator why you're allowed to do that. So let me give you an example. I'm going to substitute this x with a number and plug it into my calculator and show you that if I take that same number and put it in front of the log of 900, it's equivalent. Okay, so you know what? Hold on. I'm just going to use the x button in my calculator. So, okay, so I don't even know what x is stored as, to be honest with you. It doesn't even matter. So if I plug in my calculator log of 900 to the x power, okay? Whatever x is stored as, I can close the parentheses. This is what I get. Now, you know how I said if I were to take this x and move it to the front of the word log, it should be equivalent? Well, let's do that. Let's type in, let's move it to the front, log, x times log of 900. And if you want to close the parentheses, you can. You don't have to. And check that out. They're equal to each other. So basically, if you take an exponent and move it to the front of the word log, you get two equivalent expressions. Okay, so let me go back to the problem. So now we're trying to get this x. We're trying to solve for x. This says x times log of 900. So the opposite of times, the opposite of multiplication is division. So at this point, we can just divide both sides of the equation by log of 900. Okay, so these are going to cancel. Anything divided by itself cancels, so I'm going to bring down the x. And then this right here, you're going to plug in your calculator using the log button. Okay, so you're just going to type in, you're going to hit log of, 1400? And make sure you close those parentheses, right? And we want to take that and hit divided by, and then log. The log button is all the way on the left-hand side. It's over here, ready? It is 1, 2, 3, the fourth one up. So log of 900. And just hit enter. Okay, so you get 1.065, let's say. But look at the directions. It says to round to the nearest tenth. So the nearest tenth, this would be 1.1, right? That's 6 would tell you to round that 0 up to 1, so 1.1. All right, so let's take a look at the next one, number 31. Now, Again, we're solving for an exponent, right? When your variable's in the exponent spot, we're solving for an exponent. So that lets us know we want to use logs. But before we jump right into logs, this exponent is on the 2. It's not on the 3 as well. So we want to get rid of this 3. So because this is 3 times 2 to this power, we're going to divide both sides of the equation by 3. Let's just get rid of that 3. Okay, so those cancel, and it leaves us with 2 to the 5 over x power equals 9. Okay, so now we have the term that contains the exponent on it by itself. So now we could throw the word log in front of both sides of the equation. Oop, I'm really squeezing. I probably should have done that in the next line, huh? Okay, and the reason we do that is because the power rule says you could take your power and bring it to the front of the word log. So we have 5 over x times log of 2 equals log of 9. Okay, and then this is the term that contains the x. So I want to get first this term by itself. So let's get rid of the log of 2. Since it's 5 over x times log of 2, the opposite of multiplication is division. So we're going to divide both sides of the equation by log of 2. All right, so those log of 2's cancel, and I'm going to bring down the 5 over x equals. All right, so, I'm kind of thinking, since this is a fraction, rather than plugging this into my calculator and getting some random decimal, which I could do, I'm going to just leave this as a fraction for right now. But if you want to plug this in your calculator and write it as some it would give you a decimal, and put that over 1 and cross multiply, you can. But I'm just going to leave this as a fraction. To me, it just seems more logical. Okay, and then we can either find a common denominator when you have a fraction equal to a fraction, or you can cross multiply. I think I'm going to cross multiply this time. All right, so you multiply the top left by the bottom right, so that'll be 5 times log of 2. And then equals x times log of 9. All right, and we're trying to get this x by itself, so let's just divide both sides by the log of 9, because it's x times log of 9. So the opposite again of multiplication is division. Okay, so these cancel, and I'm left with an x on this side. I'm actually going to move over here because I'm running out of room. And then this, we're just going to plug in our calculator. Now, when you plug this in your calculator, you can use alpha y equals and plug it in as a fraction, or you could just type it in exactly like you see it. 5 log 2, close the parenthesis, divided by log 9. Okay, I did it both ways, just so you could see. Either way you do it, you get the same answer. So to the nearest tenth, that would be 1.6, right? That's 7 rounds that 5 up to a 6, so 1.6. All right, so why don't you try out 32 and 33 on your own, and then you could hit play, see how you did, and we're going to stop here. We're going to save 34 and 35 for tomorrow. Okay, so for 32, we already have the term with the exponent on it by itself, so that tells us we could jump right in to putting the word log in front of both sides of the equation. So I'm going to have log of 48 to the x plus 1 power equals log of 592. Okay, all I did was I just threw the word log in front of both sides of the equation. Okay, and the reason we do that is because the power rule tells us we could take this power and we can bring it right to the front. Okay, so when we do, make sure you put that actually in parentheses, because you want this whole thing times log of 48. Okay, and then I'm going to bring down the log of 592. Okay, so the only thing I did there was I took the exponent and brought it to the front of the word log. And I put it in parentheses to show that it's this whole expression times log of 48. All right, so we're trying to get the x by itself, and it's in parentheses, but these parentheses are being multiplied by log of 48. So we want to get rid of the log of 48. So the opposite of multiplication is division. So we're going to divide both sides of the equation by log of 48. All right, so we do those, so those cancel. So on this side, we're left with x plus 1, and you no longer need it in parentheses because the x plus 1 isn't being multiplied by anything else. So I'm going to bring down the x plus 1 out of parentheses. Okay, now, I know in the last question I kept this as a fraction. I mean, technically you could if you want. I'm not going to here because this is not a fraction. So I'm going to plug this in my calculator, log of 592 divided by log of 48. And because the directions stayed around to the nearest tenth, and we know all we have to do is subtract one whole from it to get the x by itself in the next step, you can actually, when you plug this in your calculator, you can round to the nearest tenth right in your paper. Usually I don't like to, in the middle of the problem, round to whatever the final answer wants you to round to, but since we're only subtracting a whole number from it, it's not going to change its decimal value. Okay, anyway, log of 592 divided by log of 48 gives you 1.6. And then when we subtract 1 from both sides of the equation, we get x equals just 0.6 or 0.6, however you want to write it. Okay, and then finally number 33. Well, this one, just like number 31 above it, it has a number in front of the base that has the exponent on it. So we need to get this 4 to the x plus 3 power by itself. So I'm going to divide both sides of the equation by 2. So that'll give me 4. Those cancel. It'll give me 4 to the x over 3 power equals, all right, well, this is a decimal, right? It's 11.5. If you want to leave it as 23 halves, you can. All right, so now that we have the base that contains the exponent on it by itself, we want to put the word log in front of both sides of the equation. And remember, we do that when we're solving for an exponent. That's when you put the word log in front of there. I don't think I'm going to fit it, so I'm just going to rewrite it in the next step. So log of 4 to the x over 3 power equals log of 11.5. Okay, and the reason we do that is because you could take your exponent and bring it to the front. So I get x over 3 times log of 4 equals log of 11.5. All right, so I want to get rid of this log of 4. So since we have x over 3 times log of 4, the opposite of times, the opposite of multiplication is division. So we're going to divide both sides by log of 4. Okay, so it leaves me with x over 3, okay, equals, and this time, instead of actually leaving it as a fraction, I am going to plug this in my calculator and write it as a decimal, only because when I cross multiply, you'll say, okay, so when I plug in log of 11.5 divided by log of 4, let's see, I'm not going to round to the nearest tenth here because I still have to multiply this. I still have more to do with this number. So sometimes if you round too early, it throws off your final answer. But I get 1 point, I'm going to round to 4 decimal places for right now. I mean, that's probably overkill, but 1.7618. Now, the reason I did that, right, because I have to take this and put this over 1. And when I cross multiply, x times 1 is just x. And this is why I decided to plug this in my calculator and write it as a decimal, so I'd have a 1 down here. So I just am left with x. And then this number, we have to multiply by 3. So if you do 3 times this number, to the nearest tenth, you actually get 5.3. Now, one thing I want to point out, why I rounded this to 4 decimal places. If I had rounded it to 1.8, well, 3 times 1.8 would have actually been 5.4, not 5.3. So if you still have more work to do in the problem, I would round to at least 4 decimal places, and then your final answer will be, accurate. Okay, so again, don't worry about the 2 on the bottom of the page. We're going to take a look at that tomorrow.